The United States has spent years trying to slow China's military access to advanced artificial intelligence by restricting powerful chips. But researchers linked to the Chinese military found another route. Instead of building every capability from the beginning, they used answers produced by leading American AI models to train smaller systems that could run inside Chinese networks, drones, surveillance platforms, and tactical hardware. Reuters reviewed more than 80 Chinese academic papers and patents. The documents describe researchers connected to the People's Liberation Army and other defense institutions using outputs from models developed by OpenAI and Anthropic. The technique is called model distillation, and it exposes a major weakness in the global AI race. A country may restrict the physical chips needed to build a frontier model. But once a powerful model is available through an online service, parts of its knowledge and reasoning can potentially be copied into another system. The result is not an exact duplicate. The smaller model usually loses some general capability, but it can become cheaper, faster, easier to control, and more suitable for one specialized job. Imagine a world-class teacher who spent years mastering thousands of subjects. A student cannot copy the teacher's entire mind, but the student can ask thousands of carefully designed questions, record the explanations, and use those answers to create a smaller training course focused on one subject. That is the basic idea behind distillation. A powerful teacher model generates answers, labels, summaries, or reasoning examples. A smaller student model is then trained to imitate those outputs. This is not automatically suspicious. Distillation is widely used across the AI industry. Developers use it to reduce operating costs, improve speed, and place useful capabilities on devices with limited computing power. OpenAI itself provides tools that allow developers to distill larger models into smaller ones for approved applications. The controversy begins when outputs are collected without authorization, at industrial scale, or for purposes prohibited by the original provider. The Chinese research reviewed by Reuters suggests military-linked institutions were not only studying American models. They were attempting to transfer selected capabilities into systems they could operate locally. That local control matters. A military organization cannot safely send classified information to a foreign commercial chatbot. It cannot depend on an external company that may block access, monitor usage, change its policies, or shut down a service during a conflict. A locally deployed model can operate inside a protected network. It can be modified for a specific mission. It can continue working when internet access is unavailable. One paper came from researchers associated with PLA Unit 96941. An organization connected to military intelligence and cyber operations in Beijing. The researchers reportedly used OpenAI's GPT-3.5 to process sensitive military software code. They considered third-party models unsuitable for directly handling classified information. Their solution was to use GPT-3.5 to summarize code, then train a domestic model using those summaries. The final model could run entirely within Chinese military networks. This reveals the first major advantage of distillation. The teacher model does not need to receive the most sensitive data. Researchers can use it to generate general knowledge, explanations, examples, or transformations. They can then use those outputs to train another system that later processes classified information locally. The American model becomes a temporary instructor rather than the permanent operating system. Other examples were connected to monitoring and surveillance. Researchers at the North University of China, an institution with ties to the country's weapons industry, used Anthropic's Claude 3 Haiku to generate synthetic training data for a text classification model. The system was designed for social media monitoring and content moderation. Synthetic data means the examples were generated by an AI model rather than collected directly from real users. This can be valuable when researchers do not have enough labeled information. Instead of paying people to classify thousands of posts, they can ask a larger model to create or label examples. The smaller model learns patterns from that generated dataset. But the most important applications extended beyond text. A paper from the PLA's National University of Defense Technology described shrinking an image processing model for use on unmanned aerial vehicles. A large model may perform well inside a data center, but a drone has strict limits. It carries a small computer, runs on a battery, and may lose communication with its operator. Distillation can compress selected visual capabilities into a model small enough to run directly on the aircraft. That allows the drone to analyze live video, support navigation, and potentially assist targeting decisions without continuously sending information back to a remote server. This is known as edge computing. The intelligence moves from the cloud to the machine itself. The difference becomes critical in a contested environment. Communication links can be jammed, delayed, intercepted, or destroyed. A system that depends entirely on a distant data center may become useless. A locally operating model can continue detecting objects and making limited decisions even when the network disappears. Researchers at China's Academy of Military Sciences reportedly used a similar approach for target recognition during simulated maritime operations involving drones, ships, and unmanned submarines. This points toward a larger goal. The objective is not necessarily to place one giant chatbot inside every military platform. It is to extract different capabilities from powerful general models and distribute them across many specialized systems. One model could classify satellite images, another could summarize intelligence reports, another could inspect software for vulnerabilities, another could help a drone identify objects, another could analyze communications or coordinate sensor data. Each student model might be weaker than the original teacher. But a military does not always need a model capable of writing poetry, solving mathematics, translating languages, and coding websites. It may need a smaller system that performs one narrow task reliably, quickly, and without an internet connection. This is why chip restrictions alone may not solve the problem. Advanced chips remain essential for training the most powerful frontier models from scratch. Distillation cannot eliminate that requirement. A student model cannot magically learn capabilities the teacher does not reveal. It also cannot fully reproduce the teacher's broad intelligence. But a country with limited access to the best hardware may not need to recreate the entire frontier model. It can use foreign systems as teachers, select the capabilities it values, and build smaller models requiring far less computing power. That changes the economics of AI competition. Training a frontier model may require enormous data centers, advanced processors, specialized memory, and hundreds of millions or billions of dollars. Training a narrow model from generated examples can be dramatically cheaper. The shortcut does not provide total independence, but it can reduce the distance between the leader and the follower. This is one reason model distillation has become a political flashpoint between the United States and China. American officials and AI companies have accused some Chinese organizations of using large numbers of accounts and automated queries to extract model capabilities. Chinese officials and companies have rejected accusations that their progress depends on copying American systems. They argue that Washington is using national security claims to protect American technological dominance. These two arguments can both contain part of the truth. Chinese laboratories have produced significant original research and competitive models. At the same time, the papers reviewed by Reuters indicate that some military-linked researchers deliberately used American model outputs as training material. The issue is therefore not whether all Chinese AI is copied. The issue is whether selected American capabilities can be transferred into systems that support foreign military and security objectives. Anthropic has warned that distilled models may lose the safety controls of the original system. This is another important part of the story. A commercial model normally includes multiple layers of protection. It may refuse requests involving certain weapons, cyber attacks, surveillance activities, or other dangerous uses. But the safety behavior is not identical to the underlying capability. A student model can be trained on useful outputs without inheriting all of the teacher's restrictions. Its developer can then fine-tune it for purposes the original provider would have blocked. The capability moves. The safeguards may not. This makes model outputs a form of strategic technology. Traditional export controls focus on physical objects. Chips can be counted, inspected, licensed, and stopped at borders. Model knowledge is more difficult to contain. It can leave through millions of ordinary-looking online responses. No single answer reveals the entire system, but a carefully designed collection of prompts can map how the model performs a particular task. Preventing this creates difficult trade-offs. AI companies could impose stricter identity checks, monitor unusual query patterns, limit the number of accounts, and block suspicious automated use. Anthropic says it is developing product-level, API-level, and model-level systems to detect and reduce unauthorized distillation. But stronger restrictions can also harm legitimate developers. A startup may send large numbers of similar requests because it is building a legal application. A university researcher may study model behavior. A company may use approved distillation to reduce costs. The provider must distinguish a normal customer from an organization quietly extracting capabilities. That is not easy. Attackers can distribute requests across accounts, countries, and intermediaries. They can vary prompts, slow the collection process, or use third parties. Even perfect access controls would not solve the larger problem. Open models can be downloaded and studied without contacting the original developer. Commercial models can be accessed through resellers, cloud platforms, or compromised accounts. And once a capability has been distilled, it may be impossible to prove exactly where it came from. The United States, therefore, faces a strategic contradiction. It wants American AI companies to sell products globally and establish their technology as the international standard. But every new user also creates another opportunity for capabilities to spread beyond the company's control. Closing access completely could reduce extraction, but it would also surrender customers and influence to competing models. Keeping access open supports business growth but increases security risks. China faces a related contradiction. Distillation can help it reduce dependence on foreign computing and accelerate specialized applications. But Chinese researchers are also studying how their own models could be copied through the same method. Researchers at the Army Engineering University have examined data-free distillation, where an attacker attempts to reverse engineer a model without access to its internal parameters or original training data. They propose defenses designed to hide some of the logical information exposed through public outputs. The same technique used to catch a competitor can later be used against the person who adopted it. This shows why the AI race is moving beyond chips. The first stage focused on who controlled the most advanced processors. The next stage will also focus on who controls model access, training data, generated outputs, software ecosystems, and the ability to detect capability extraction. Chips remain the industrial foundation, but models have become strategic assets in their own right. The Reuters findings do not prove that China has recreated the most advanced American AI systems. Distillation cannot fully replace frontier training, and smaller models remain limited. What the findings show is more subtle. American AI can influence foreign military systems even when American companies do not sell those systems, approve those applications, or directly transfer their model weights. The knowledge can move through answers. A model designed to help businesses, programmers, and researchers can also become a teacher for surveillance tools, cyber systems, drones, and target recognition platforms. The deepest lesson is that controlling artificial intelligence may be harder than controlling any previous technology. A chip is a physical object. A model is a pattern of capabilities. And once those capabilities can be demonstrated through an interface, someone will try to learn from them.